Okay, I'm making a quick video, MJ here, on some of the common errors I'm seeing in algebra so that you can not make them. So, the first one, let's start with a general sort of question here. We got x take away 8 equals negative 12. All right? So the first thing people say, is this take away 8 or negative 8? The answer is it doesn't matter, okay? It's gonna be the same work regardless. Okay, so I go through my steps. Is there any math to be done? No. Can I, are there any numbers to put together on either side? No, they're both on opposite sides. Is there any x's or variables to put together on either side? No, there's only one variable, and it's all by itself. So I don't have to do any basic math. So I go on to step 2, which is to get the variable alone, which means I don't want the 8 here, okay? So I need to add 8 because that, 0 pairs it out, and I'm left with nothing. So the mistake kids sometimes make is I've seen both. So I've seen they put a negative 8 here, I guess because there is a negative 8. No, the whole point is to make it nothing so that there's no numbers left, right? That's what we call isolate the variable, get the variable alone, which means we have to get rid of that term, okay? We gotta get rid of the negative 8. So it has to be positive 8. The other mistake people make is for the Thanos rule is they don't add 8 on this side. For some reason, they subtract 8. And I think that comes from when teachers say, like, oh, you just move, quotes there, you just move something across the equal sign and the symbol changes. I think that's the mistake they're making, but that's not what we're doing, okay? Whatever we do on one side, we do the other side, so it has to be positive 8, okay? Now the 8s are gone. I'm left with just the x on one side, and then negative 12 plus 8. This is another mistake I'm seeing is kids are just adding their integers wrong, which I'm not really sure what to say about. That unit's come and gone. But imagine it's 12 degrees, negative 12 degrees out. The temperature goes up 8 degrees. It's getting closer to 0, so we're left with negative 4, okay? And as always, plug in your work. So negative 4, take away 8 equals negative 12. Is that true? Yes, check. Okay, now I'm not going to check all these because this is going to take too long. But on the test, I'm going to give you very few questions, so do make sure you do check your work, okay? Next one. So next one is one where we have multiple of a variable. So let's go with 3t equals 12, okay? So for this one, we have to divide. So this is 3t. So that means there's literally, 3 t's, okay? And one of our steps is make the variable just 1. That's step 4. So we didn't have to do it for this one because we only had 1x, but in this one we have 3t, okay? Here's the most common mistake I see kids making, which is definitely going to give you the wrong answer. Is they're like, okay, I know there's 3t, and I know I want 1t, so I take away 3, right? And that leaves me with just a t. Well, you can't do that, okay? Because this is not 3, the number. This is 3 of t. It's 3 groups of t. It's 3 times t. So you can't just take away the 3, right? You are, they're on the right track. We do want to get rid of the 3 because we want to make it 1, but you can't just take away 3 from it, okay? That does not work, all right? And that's a mistake I see too much, okay? So do not make that one. So let's just clean that up a bit. So 3t equals 12, okay? What that does mean, it's just like over here. When we had negative 8, we added, right? When you want to get rid of something, you've got to do the opposite. So since this is 3 times t, we're going to divide, okay? And we're going to divide by 3 because when I have those 3 t's, if I cut them into 3 groups, I'm left with just a single t, which is what I wanted, okay? So now I'm left with just a single t. And Thanos rule, whatever you do to one side, you do to the other, and we're left with t equals 4. Okay, it doesn't make sense. Yes, 3 times 4 equals 12. So that checks out. So make sure you're not subtracting the coefficient. Okay, you can't do that. You gotta break it apart. It's not just taking it away. You gotta like smash that thing. So smash that like and subscribe button, by the way. So that's where we're dividing by 3. Okay, you can't just take away 3 there. So that is unfortunately a common mistake. But usually kids stop making that after a while. All right, next question. Negative 4 plus q equals negative 7. Okay, so for this one, it's a little trickier than our first question because we've got some negative numbers here, although we did have negative numbers earlier. But sometimes that can confuse kids. So the main confusion I see for one like this is that kids don't know what to do with that negative 4, and they try to take away 4 or do whatever. We do need to, again, do the opposite. So we're going to bring in positive 4 because that's how we're going to isolate the q, okay? Thanos rule, whatever you do to one side, do the other side. Those are canceled out. Q equals, and then again, it's negative 7 out. The temperature goes up 4 degrees. It's getting warmer, closer to 0. So I'm left with negative 3. My bad. Okay, does that check out? Negative 4 plus negative 3 equals negative 7. That does check out. okay? So that's another sort of common little mistake. Now, the next one we're going to do is this one, and I'll show you what the common mistake here. You might be able to guess already, but it's one where we have variables on both sides. So I've got 4 plus p equals 2p, okay? And kids don't know which side to keep the variable on. So that's the mistake I'm seeing most often. And the answer is you want to keep the variable on the side with the most of the variable. So since there's 2p here and only 1p here, we're going to keep the p's on this side, keep the p's. And could you do it the other way? Yeah, but then you're going to end up with negative p's, and things are going to get a little more complicated. You can do it, but it's going to take longer. So it makes more sense. It's easier to keep the variable on the side with the most of the variable, okay? So since we want the variable over here, that means we got to get rid of the variable over here, okay? And this time we can subtract p. But MJ, whatever you do once I do that, MJ, you told us up here we couldn't take away 3 to get a single t. Yeah, you could take away t's from up here. You can't take away the number. You can't just take away the number. But you could take away 2t from up here to leave you with 1t, but then the problem would be you'd have to take away 2t from the other side where there's no t's, so you'd have negative t's and things get more complicated, okay? So you can subtract variables, but you can't subtract the number from a term, okay? So down here, I'm not taking away the 2, I'm taking away, what I'm really doing is taking away a single, I'm taking away 1p from each side, okay? And that way, negative and positive, that's 0 pair, those are gone, and I'm left with 4 equals, and in this case, it's a single p, because 2p take away 1p is just 1p, and I'm done. P equals 4, okay? Yeah, I know it says 4 equals p, but who cares? It can be on the other side. Does that make sense? Does 4 plus 4 equal 2 times 4? Yeah, they're both 8. So that checks out as well, okay? So that's the mistake I'm seeing is people want to leave the variable where there's already one variable because they know they want one variable, so why not just leave the p all by itself? But that means you got to take away 2p from this side, and you end up with negative p on this side, and things get more complicated, okay? So keep the variable on the side with the most of the variable, okay? What's next? I got one written down here. 8 equals t over 3, or t thirds, plus 5. Okay, so I think people are just kind of scared of these because it's got a fraction, and fractions are kind of spooky. But they're actually easier than the ones where you have to do like some multiplication or whatever. So, or sorry, some division, like in this case. So I find that this one is actually trickier than this one. But this one just looks spooky because it's got a fraction in it. But it's actually, in my opinion, easier because you're going to multiply to fix it, okay? So again, same thing, there's no math to do. And I know I want the variable alone. Well, the variable is a t, okay? And there's no variable on the other side. So the t has to stay here, which means that the 5 has got to go. So again, same old deal, okay? I'm going to 0 pair those out. Thanos rule, that's gone. A to a q5 is 3, and I'm left with t over 3 equals 3, okay? Now remember, when we wanted to get rid of a positive or negative number, we did a positive number. When we wanted to get rid of somewhere else, I don't know, whatever. When we get rid of a positive, you get rid of a negative, okay? Or you bring in a negative. When you want to get rid of multiplication, you divide. Well, when you want to get rid of division, because t over 3 is t divided by 3, right? When you're going to get division, you're going to multiply. So we know we need to multiply to fix this. The only kind of question is how much we need to multiply by, and the answer is 3. Okay, it's by the denominator, and I'll show you why in a second. So when I'm done that, I get a full t. Oh, I could go for a full t right now. Sorry. And that equals 9. Okay, does that check out? 8 equals 9 over 3, which would be 3 wholes, plus 5, which equals 8. 8 equals 8, that checks out. Okay, so MJ, I get that you use the denominator and you multiply by the denominator to get a full t. Cool. Like, why does that work? Well, imagine it was 1/3. Okay? And we got 1/3 and we want it to be instead 1 whole. Well, how many 1/3 do we need? We need a second 1/3 and a third 1/3. Okay, we need 3 1/3 to get to 1 whole. Okay, and so that's why if we multiply t thirds, or t over 3, by 3, we end up with the number on top, the numerator, being a full t, not just t thirds. Okay, okay, MJ, that works for 1. Would it work for other numbers? So let's try it. If I had, well, let's not do 3. If I had 4 thirds, and I want it to be a full 4, okay, I want it to be a full 4 wholes, not just 4 thirds. Would it work if I multiplied it by 3? Well, let's find out. 4 thirds times 3 is 12 thirds, which is 4 wholes. Okay? So that's your proof that multiplying it by the denominator will give you a full numerator. In this case, we wanted the full t. Okay? So the most common mistake I'm seeing there is people are not sure what to multiply by. Like, do I multiply by t, or like, is it always by 2 or whatever? No, it's always by whatever your denominator is. And there's your proof as to why that will always work. Okay, last one. So this one's negative 1 wholes, equals 5 plus x over, 5 plus x, oh my god, let's start over here. Negative 1 equals 5 plus x over 6, okay? And this one's kind of spooky because we've got negative numbers, we've got not just a variable in the fraction, but we've got a variable and a number, okay? And so to solve this one, same thing. There's no sort of math to be done. We need to isolate the variable. Okay, but it's like in a weird question. And MJ, you just told me I'm going to multiply by the denominator. So, okay, I will. And you'd be right. So we're going to multiply by 6. And then Thanos rule, same thing, same. Okay, negative 1 times 6 is negative 1, negative 1, negative 1, negative 1, right? So that's negative 6. And yes, okay, opposite symbols mean that it's going to be a negative. That's a trick. Anyways, over here, this is where people then make their mistake. They're like, oh, when it was t over 3 and I multiply by 3, I got a full t. So does that mean when I multiply by 6, I'm going to get 5 plus x wholes? Or do I get 30, right? Because 6 times 5 is 30. Do I get 30 plus x? And that's the mistake. So that's the question. Is it 30 plus x when I multiply by 6? Or is it 5 plus x? Or maybe is it 30 plus 6x? I don't know. So I guess those are the mistakes I see. And the answer is that it is just 5 plus x. Okay? And that's for the same reason as earlier. When you multiply by the denominator, you're left with the number on the numerator, or whatever it is. In this case, it was a variable in the numerator. So since 5 plus x is our numerator and 6 is our denominator, when we multiply by 6, we're left with the numerator becoming whole, which is a whole 5 and a whole positive x. Okay? Now we would just do regular good old-fashioned algebra here, and we would subtract to 5 to leave us with the full x. And then over here, negative 5, negative 6, and negative 5 together, right? We're going from negative 6, and it's negative 6 out, sorry, and it drops an additional 5 degrees. Then we are all the way down to negative 11, okay? Now, for this one, since it's our last one, let's actually double check our work, and let's see if that makes sense. So negative 1 equals, and now the 5 is still a 5, but our x we're saying is negative 11. So yeah, you could say plus negative 11, but you can also just say take away 11, okay? Over 6. So let's see, does this work? Well, 5 take away 11, so it's 5 degrees out, and it drops 11 degrees, which means it's now negative 6, right? Over 6. So negative 1, sorry, I'm running out of space on my paper here. Negative 1, let's just kind of box that out. Okay, negative 1 equals negative 6 over 6. Well, negative 6 over 6 is negative 6 divided by 6, which is negative 1. So negative 1 equals negative 1. That checks out. Okay, that is admittedly a weird one, and there's kind of a lot of a step suit, but the mistake is that when there's not just a variable over 3, in this case there's 5 plus x over 6, kids aren't exactly sure what to do with the number portion of it. But remember, by multiplying it by 6, we're making the numerator whole. So by multiplying by the denominator, the numerator becomes whole. Whatever happens to be in that top of the fraction becomes a whole version of itself, not a, in this case, 6th version of itself. Woo! Okay, so those are the most common mistakes I'm seeing besides just, random sort of calculation errors that some people are making. So I'm pretty sure I only ask you sort of 3 algebra, like straight up, like here's an algebra question that you'll never see, in real life on the street to solve. So do them right, double check your work, and hopefully this video helps with any common mistakes. Peace.